All right, we are live and recording. I am going to, let's see, I'm going to toggle your video for a minute here, Mark.
Okay.
All right, well, welcome everyone out to UJUG this month. So we've got, like I said, we've got Mark with us this month. We're excited to have him here. All the people that are here, and I'm sure we'll get people that'll trickle in as well. Let me double check and see if we're actually, yep, so we're going live on YouTube as well, so this is great. I don't have any slides, but I will talk about what's going on next month and the month after, and of course sponsors. So if you haven't been to the website, let's go over here, ujug.org, share tab. All right, so we've got our list of sponsors over here on the website. We've got Applitools, Lucid Software, Overstock, Goldman Sachs. They returned this year. Actually, I think, no, who did we have come back? Zion's Corp has come back. We still have JFrog. We've got Tech. They've been with us for a long time. STG, our longest running sponsor. SoFi. And then, of course, JetBrains, where we'll be giving away a couple of licenses for JetBrains tonight. And also a subscription to Vencat's Agile Learner as well. And we would like to thank Overstock, they came back. I'd like to thank everyone that's out here, and especially the sponsors. If there's any sponsors that are here, definitely say hi. But we're glad to have the sponsors to allow us to continue to do these things and to present a great topic that we've got and people that are out here. Love to have them with us. And as far as what's going on next month, we want to be over here. So next month we have Nate Shuda talking about architecture, cloud, microservices, all that kind of stuff. And of course, following that, we will have an AMA style interview. And then for September, we also have, oh, where to go? My notes are over here. In September, we have our own Steve Afrin talking about changes changes in Java from Java 11 all the way up to 17. So he's going to go over some of those changes. He's got a Git repo that you can pull down, mess with stuff on your own time as well, and see how those things work in real time and all of those different changes, and hopefully bring some of those back to your workplace as well. In October, we've got Garrett Gunwald, who's coming back off of, no, this will actually be before Java 1. So I don't remember the topic off the top of my head. And then to close out our year, we've got Jeremy Davis, which is going to be talking about, I think that was microservices. I think he's from Red Hat, so we're grateful to have him with us as well. So glad to have all these great presenters out here and welcoming anyone that's out here as well. So I think that should do it without any further ado. If anyone's got questions for us tonight, feel free to use the Ask a Question down at the bottom. You can ask a question, people can upvote it, and then I can also tag it in the stream for people that are going back and watching it afterwards so that we can timestamp when those questions are answered. So we'll go ahead with that. Mark, I'm going to bring you back up on stage.
All right.
There you are. And without any further ado, I will turn the time over to Mark.
Awesome. Thank you so much. It's great to be back. I was just thinking about the last time I was there in person, and boy, we filled up the room. I think there were almost close to 300 people, and that was of course before everything happened. And so it's great to be back, even though it's virtual and stuff. But so Don asked me, we were going to just do ask me anything kind of session, and he said, well, you want to start out with a topic? And I said, I think that'd be great. And so I selected kind of a topic that is one of my favorites, architectural thinking. And I'm going to start showing the slides and stuff like that. And as I'm going through, the presentation will be about 45 minutes or so. Gather up your questions, because after I finish, we'll do another 45 minutes of just Q&A about architectural thinking or about anything, as a matter of fact. So I was just actually just chatting before we started I was just in Utah, as a matter of fact. I took a very long vacation and spent a couple of weeks hiking in southern Utah, and that was fantastic. I had a great time. Of course, monsoon season, as most of you know, there in Utah started early, so it was early morning hiking and afternoon rain showers. but but I camped the whole time with my wife. We had a really fun time, so it was absolutely gorgeous. Anyways, let me start the slides here and share my screen for everybody here and get that started. And let's see. Yep, there we go. Okay, and fantastic. So you should see a slide that says architectural thinking with my picture on it. And what this real topic is really about is kind of how to think like an architect and why it's so critical, even as a developer, to start thinking architecturally. So that's what we'll kind of talk about in the first 45 minutes here. So you'll have to forgive me. I do get very, very excited about this topic. So if I get all energetic and stuff, forgive me. I just love this topic. Now, I'm actually going to pull material out of both of the most recent books that I wrote with my friend and colleague Neil Ford, The Fundamentals of Software Architecture, which we published in 2020. And then just last November, published Software Architecture, The Hard Parts. And as a matter of fact, I'm going to combine some of the concepts from both of these books in terms of what it means to kind of think architecturally, seeing things with an architect's eye. And as a matter of fact, here's an interesting place to start. So let's say I show you a picture of clouds. You know, it's kind of interesting. Depending on who you are and what role you play and what your interests are, you see these clouds differently. If you're a meteorologist, you start to see the type of cloud and you can kind of predict some of the weather patterns that are going to exist. If you're an artist, well, you look at those clouds and suddenly you're visioning this gorgeous, beautiful, dramatic colors and painting and stuff like that. As a matter of fact, if you're like me in IT, you look up at the clouds and of course you think cloud with the Internet of Things and such. So if that's the case, what does it kind of mean then to think architecturally? Like, see things with an architect's point of view. When you look at something, you can see it just like the clouds that we just saw, with a different point of view and different perspectives. And that's what I want to show you. But I want to kind of back up first and actually start out by really asking why architectural thinking is really so important. And it is. It's really critical. And let me give you an example why. As a matter of fact, I'm just going to start straight out with a technical example. So let's say here, and as a matter of fact, I'm going to draw my slide a little bit here, that we've got an order placement service. Boy, we just cannot seem to get away from microservices, huh? Well, actually, this is a kind of event-driven. But let's say we've got an order placement where we can place an order, a payment service, and then an inventory service. Now, once an order is placed, I'm going to use event-driven architecture to send a message or an event to a topic or a queue that, in this case, it's a topic that both payment and inventory will receive. Pretty simple example. I've got a database here as well. But here's the thing. Should that event payload include all of the data necessary for processing, or just the keys? In this simple example, it's one of the choices that we have to make. And when I say we, usually from a developer perspective, key-based payloads or every bit of data. So let's actually take a look at the trade-offs associated with those as an example of why architectural thinking is so incredibly critical in most of the things we do. So here's what happens. Order placement passes all the information into the database. But let's say that we pass all of the information in the message payload. In other words, here's all the data right here, but the entire message, let's say it's 45 attributes of that order, goes both to payment and inventory. Well, clearly, the reason why you would choose to do this is scalability and performance. Isn't it interesting? We think it's faster because now payment and inventory don't actually have to go out to the database. I'm passing all the information you need, just process it. We think about it with performance, but isn't it interesting? It's also about scalability because the less time we're in a database, the more available that database is for other processing that does need a database connection. And so I don't have connection waits, and it's a lot faster, hence more scalable. So this seems like kind of an obvious choice. However, think about the impact of that decision of passing the entire order and all attributes in that message. Because while we get scalability and performance, all of a sudden, we have contract management and versioning issues. In other words, what's that contract going to look like? When it changes, how am I going to manage versions? Is it a tight contract with a schema? Or is it a loose contract, schemaless, just such as maybe some JSON name value pairs? I have to now make all those decisions. As a matter of fact, the worst part of it is something called stamp coupling and bandwidth. You see, with the stamp coupling, if I make a change to that contract, payment doesn't need all the information. Inventory only maybe needs a little bit of it. However, the problem is order placement obviously has to change. But both of these services need to change. Anytime I make a change to that contract, whether they need that particular data or not. And that's what stamp coupling is. Now, one of the other implications of choosing this kind of thing is also bandwidth issues. Because that entire payload is 500 kilobytes, 45 attributes, let's say, which means that unfortunately I'm passing around 500 KB through the network, even though I may only need 2 or 3 fields within payment, or even 2 or 3 fields out of the 45 for inventory. And so the problem is, let's say payment only needs 350 KB. As a matter of fact, inventory only needs 50 KB worth of information, but yet I'm passing around all this data through the network. The other problem by making this choice is that we've got multiple systems of record. Because I'm passing the entire order information in, all of a sudden we realize, wait, what's the system of record? What's really the truth? And because, especially with event-driven architecture, if I were to make a change to that order immediately after I submitted it, now I've got 2 messages all of a sudden floating around. Which one's accurate? Event timing is really, really hard. Oh dear. Well, there's a lot of implications. So what if we did choose just to pass the key? As a matter of fact, it's a simple name value pair. Order ID 123. And then just let all the services that need additional information get it from the database. Well, Mark, you can't do that. Well, why? I say. Well, because it's not going to scale. The performance is going to be horrible on that. So you make the choice to say, yeah, we can't do this. But look at the other side of it. I've got a single system of record. So I've got great data concurrency. Even if things are updated, I've got one representation of that data. As a matter of fact, there's no stamp coupling, no bandwidth issues, and also I don't have a contract to manage. It's just a simple name value pair. So all of a sudden we realize these simple kind of decisions that I just went through here in this one very simple example has far-reaching impacts to our system. Making the wrong choice could all of a sudden mean I don't scale or I don't perform as well. Making the wrong choice means all of a sudden changes are going to take forever because of contract management and versioning. My networks are going to be slow. I've got data consistency issue. Which one is more important? And that's why it's so critical to think architecturally. Because everything that we do has some sort of trade-off. And we need to determine which is more important. So thinking architecturally really is about three things. First, it's understanding the importance of business drivers and how those translate to architectural concerns. You see, without understanding these, how can I possibly make even the simplest decision about message payload if I don't understand those business drivers and what's important? Is managing contracts very important? Or is it scalability? Or is it performance? Or is it network utilization? Because that in cloud translates to cost. But thinking architecturally goes beyond just understanding those business drivers. It's also having a wide breadth of technical knowledge while still maintaining that technical depth and thinking like an architect. That architectural thinking is also about identifying and analyzing and reconciling trade-offs to be able to make the right choice in any of the technical choices that we have. So what I want to do in this session is really kind of go through all three of these factors. And what's really cool, everyone, is you don't have to be an architect to think architecturally. As a matter of fact, it's usually a development team or a tech lead or a senior developer who's actually making those kind of decisions. And so let's take a look at all three of these aspects so that once you kind of walk away from this session and all the questions that we'll have about this or anything else, it'll allow you to kind of see things with an architect's point of view. And as a matter of fact, the grounding, one of those first and most important, in my opinion, factors in architectural thinking is understanding those architectural characteristics, those ilities, which some people call them, non-functional quality attributes, these sort of things. As a matter of fact, one of the things that we start to look at is what is the language that we translate these from? You see, the language of the business, things that the business is concerned about, are things like time to market, or sometimes called speed to market. How fast can we get a change or a bug out to our customers or our users? Maybe it's user satisfaction, mergers, acquisitions, regulatory compliance. Maybe it's just in this really difficult market that we're in, just simply to maintain a competitive advantage. So these are all kinds of business drivers, concerns, irrespective of the kind of applications that we're building. But the problem is, this, folks, is our language in IT as an architect. And we think about things of availability, reliability, adaptability, recoverability, portability. I mean, these are words that we use. These are the ilities, because most end in the word ility. But basically, you can almost take any word and add ility to it, and you've got a new architecture characteristic. But the real art of architectural thinking is basically acting like a translation engine. In other words, what the problem occurs is this lost in translation, where the software architect's talking about one thing, fault tolerance, and the business stakeholders talking about something entirely different, like user satisfaction. And this is one of the problems that occurs between product owners, business stakeholders, business sponsors who really have a genuine concern and need, and us in IT who have an entirely different language. So the question starts to become then, as an architect, or I'm just going to say an architect, but an architectural thinking. I mean, how do I know? How do I find out which architecture characteristics are important? Because most cases, these aren't written out for you. We as IT professionals, architects and developers have to extract these. And they really come from three different places. The first place they can come from is the domain itself. In other words, we're building a new stock trading system. I mean, right away, not knowing much about that or the actual requirements, we know we've got issues with performance, low latency. These are some of the immediate things we can all of a sudden, just extract from the domain itself, whether it's retail, whether it's banking, whether it's, high data consistency, all those things. Sometimes they actually do come from requirements. In other words, we must support 20 to 200,000 concurrent users. That's our range. Well, that just describes elasticity. The key point here is a lot of times the requirements don't state, we need highly elastic systems. No, well, it's for up to us to know those definitions and be able to interpret those as part of that architectural thinking. But a lot of times it actually comes just from listening to the business, listening to the product owner, the concerns of the business, the direction of the business. We're aggressively expanding our business. Does anybody care? Well, if you're thinking architecturally, the answer is absolutely you care. I wish this was in person or more interactive, because at this point I would be asking you, what architecturally thinking wise would that statement, we're aggressively expanding our business, even mean? And so you can kind of think of some of those. For example, scalability comes to mind. Capacities within our servers, within our virtual machines, within our database, within our connection pools. Those are some of the things that immediately comes out. Oh, how about if we're expanding our business? New features obviously are going to be added. So how agile and open are our systems? These are some of the things when you hear these statements, that's all about architectural thinking. So let me show you a couple of examples of how this first factor, and in my opinion, one of the most important factors, because it's a grounder, it's a grounding factor, actually works. So your business is concerned about user satisfaction. As a matter of fact, if we don't achieve it, no one's going to use our products or systems, and we'll probably have to fold our doors. Well, the answer is not user satisfaction ability. But what this does is this kind of goes into like a translation engine. When we think architecturally about that business need, this is what pops out in that translation engine. Things like performance, agility, the ability to respond quickly to a change or a bug, security, availability, fault tolerance, recoverability, even testability, because testability as an architecture characteristic is the completeness and ease of testing. But more about the completeness of testing. We don't want to introduce bugs. So isn't it interesting? If you look at this list right here, which I could probably come up with a couple of more items. As an end user, take a look at every one of those. And if it wasn't supported, would you be happy? Would you continue to use the product if you had other choices? The answer is no. So it's interesting that user satisfaction does not just equal high performance. No, it's a combination of all these things that need to go into that particular architecture, and now give us a grounding to be able to make a decision. How about time to market? Now, time to market, sometimes called speed to market, is how fast we can fix a bug or add a new feature before our competition does. We put that into our little translation engine, think architecturally based on that, and here's what pops out, these three main factors. maintainability, testability, and deployability. And so these are the three pieces. Maintainability, how easy is it to locate the problem or where the new feature needs to be added and actually code it? Now, that may be a short amount of time, but if we have a 6-week testing cycle where we have to regression test every bit of our monolithic application, nope, our competition will eat us for lunch. Yeah, same with deployability. That's about the frequency of deployment, but also the risk that we incur. Now, what I'm going to show you is how all these play into different kinds of architectures, because some architectures support this, others don't. And so thinking architecturally is identifying these so that we can even make the right choice of what kind of architecture we should have. Oh, what about mergers and acquisitions? Yes, this is happening all the time and has probably for about the past 20 years or more. Let's put that in our little translation engine. Look at all the stuff that pops out. How interoperable are our systems? Scalable? Are we using standards? How extensible are our systems? Are they closed systems that we require just a user interface? Because we're probably going to be integrating with other systems from other companies. And so portability, openness, adaptability are all necessary features of our applications and architectures to support mergers and acquisitions. All right, why does all this stuff matter? Well, because first of all, it provides a grounding for analyzing trade-offs, but also allows us to validate whether we have the right architecture in place. And so, for example, this is a kind of a star rating chart from our book, The Fundamentals of Software Architecture, where Neil and I both spent about 7 years coming up with these ratings. Now, 5 stars is something that is the best movie. You got to see it. That means it's an architecture characteristics that is supported extremely well natively in that architecture, whereas 1 star, it's definitely a movie you don't want to see. And that means that that particular architecture characteristic is not well supported. And as a matter of fact, if we take a look at this and just pick one, for example, scalability, that we have determined is one of our driving characteristics. We have to be able to scale. We start looking at the cross-section of 5-star ratings, and all of a sudden we find, well, microservices, event-driven, and space-based architecture all support high levels of scalability. So if we have a layered architecture or even a service-oriented architecture, it's not going to scale very well. And so this is one of the ways of being able to really validate an architecture and know whether we have the right architecture in place. You know what's so fascinating about this rating chart? You may be sitting back saying, well, Mark, that's all interesting, but we don't develop a whole lot of new applications. Yeah, most companies don't. We're still supporting all the old stuff from 10 to 12 years ago. But let me ask you this. Has your business changed significantly in the past 8 to 10 years, or even past 5 to 10 years? Have the concerns of your business and those business drivers and needs changed? Because in most cases, that answer is yes. And by continually analyzing those business needs and those changes, we can start to see we currently have an architecture that was well suited 5 to 10 years ago, but doesn't meet the needs of the business today, because those architecture characteristics, those business needs change. What about cost and simplicity? If we don't have a whole lot of money and we really need to get something out quickly with the minimum budget possible, well, there's our range, folks. And we start looking, that's probably going to be a monolithic single deployment application, because that's where cost being 5 stars means it's pretty cheap, means cost is good, and the simplicity is good as well. And that's where we start to look at the differences between monolithic and distributed architectures.
Hey, Mark,
Now,
can I break in for a minute?
you absolutely can. Yes.
All right, so we've got a question about the slides being available afterwards. Are you going to make those available to us where we can link to them or somewhere?
I wasn't planning on it because we do have the recording actually available. So I wasn't planning on making the slides actually available. We are recording this. Is that correct?
Yes, we are.
Yeah. Okay. Perfect. So yeah. So we'll have the recording at least available if you want to kind of go back and fast forward and look at different pieces of that. So
I think maybe one of the questions. So we're covering up kind of that bottom left section. So that last row on your table currently starts with WO. What is that one?
Oh, that's workflow.
Oh,
Ah,
workflow. Okay.
yeah. So, oh, okay. It looks fine on my screen, but it works on my computer.
Because none of us have ever heard that or said that before.
Right. Exactly. Yes. um, well, one of the things though that I can offer you is a worksheet that I actually use. And here's the couple of the links. They're both available from my website. Um, the lesson here is a quick 10-minute video on actually how to use this worksheet, and then the worksheet itself in PDF, PowerPoint, and Keynote format is available on the top link there. This is a worksheet that I use at work. And it really works well to kind of identify the driving characteristics here. Notice a couple of interesting things. Here's some candidate ones. These are the most common. Usually I provide a definition of each of these because it sometimes does vary based on the context of the particular project. However, a couple of things you'll notice is there's only 7 slots here, and I do that on purpose. If you ask any project sponsor, product owner, business analyst, hey, what's out of this list right here? What's important? What are those things you like? Well, certainly performance. We've got to have availability and scalability. Well, all of them. And you'll always get that same answer. All of them. And here's the problem. First, you will never find an architecture that suits all of these. Number 2, you'll never be able to make a decision or analyze trade-offs. And number 3, a lot of these architecture characteristics are opposing forces. For example, performance and security. The more secure you make a system, generally the less performance and responsiveness you'll have because of that security latency. So availability and performance work in the exact same way. So the more architecture characteristics you have, the harder your problem is going to be to solve. I have found 7 works pretty well, plus or minus 2. There are some that are implicit that obviously we would always take cost and time into account. We would always create maintainable systems until they become driving forces. Then they move from something that's implicit to a driver. But please feel free to grab this worksheet, start to fill it out. I, as an architect, fill this out, and then I schedule meetings with the business stakeholders to validate these and have them select the top 3, which is a great exercise. Out of the 7 max, which top 3 you cannot live without? And it gives you more insight as in terms of architectural thinking to actually make a decision. Now, before I leave the architectural characteristics piece, I really want to talk about measurements because it's not enough in architectural thinking just to identify these and continue to evaluate them. And that's based on the rate of change of your company. But here's a couple of questions. Is scalability getting better or worse over time? As we keep making changes, acquiring new businesses, is it staying the same, getting better or worse? Are the changes that we're continually making to this system impacting any of those architecture characteristics that we deemed valuable or important or drivers. And if we're trying to achieve a certain level, let's say, of a scalability or availability or reliability, how close are we to getting there? These kind of things, called architectural fitness functions, actually allow us to objectively measure these architecture characteristics to answer all three of those questions. Do your systems still scale? It's the same scalability as it was 4 months ago? That's important information to know. All right, so an architecture fitness function, there's a lot that are out there that are in product form, but it really also is a matter of just simply taking a service, a front end, an application, a back end system, and basically just like, for example, streaming information metrics such as
We
respond.
got a question mark.
Oh, sure.
All right. So this is coming from Justin Andrews, and he says, how do you manage business driver changes in architectural design decisions? It takes a while to undo decisions made in the past, especially when new requirements are always coming.
Yeah, exactly. So the easiest way to mention or to answer that question is that architecture is always iterative. We think about it as a snapshot in time, but it's not. And as a matter of fact, one of the things I use to help facilitate changes to architecture, in other words, to structure, are architecture stories. And in most agile environments, of course, we have technical debt, we have user stories. I usually create architecture stories, and I separate them from technical debt because if you think about it, the architecture supports the business needs and concerns, all of those ilities that we have to support. That's not technical debt. Your application can function perfectly and crash because we have too many users. It's useless. The system's useless without that. And that's what the architecture itself supports. So it's not uncommon to continually have changes, especially in microservices these days, and also to some degree event-driven architecture, where we add new features, we add new functionality, which all of a sudden, let's use a simple example, requires data from a service I didn't need before. Now, all of a sudden, I have to go ask a service for that data, and then I have to ask another service for some other information for a new feature. And if we don't pay attention to this, all of a sudden, all services are calling all other services to grab data and link functionality and workflows, and we end up with a big ball of distributed mud. So there's so many answers to this question. So basically, it's number one, educating the business. That means the product owners, the business stakeholders, the sponsors, maybe the analysts, that we will be making changes to the architecture. And that's actually a good thing, because in a lot of cases that I've been at, it seems that the architecture is like a building. Well, once you get the structure of the building up, yeah, you can change the inside and stuff, but don't go changing and adding another floor to the skyscraper. But we're not building buildings, folks. We're building software. And that's where that building analogy completely falls apart. If the architecture of our systems is not flexible, then we won't be able to support change. And so that first piece is really education, to say, if we're not changing the architecture, then something's probably wrong. Recording these as architecture stories allows that negotiation to happen with the product owner for functionality that we need to add, but also maybe breaking apart a service, putting 2 or 3 services back together, converting something from choreography into orchestration, maybe moving something to async where it was sync before. All of these things are structural changes in nature, and those are architectural. Yes, it is common that this does happen, and architecture refactorings are a result of this. It's really a matter of justifying why we need to make these architectural changes. And as a matter of fact, going back to this guy right here is a perfect way to justify that. You know, if we're currently doing, let's say, I don't know. Let's currently say that we've got a modular monolith. Okay, that's a good example. And all of a sudden, we have high fault tolerance needs, where if a fault occurs, we have to have still portions of that system running. Well, that's not going to work in our modular monolith. So fast forward over to maybe microservices, service-based, or even event-driven. And that would facilitate a migration, probably first to service-based and then microservices, to facilitate some of those new requirements that come up. And so, yeah, great question. Oh, I could spend the next 45 minutes on that question. But let me talk about those measurements, because all we can simply do is just send, let's say, for example, metrics, uptime, response times, failure rates over to Kafka. We have a capture service, a simple microservice that's just in a container, drop it into our ecosystem that listens on those topics and captures these metrics. We write another microservice that now analyzes those behind the scenes and starts tracking trends, maybe thresholds. And then if a certain trend is reached or threshold, then notify me. Otherwise, don't bother me. These are the mechanisms to be able to now measure to find out, again, if things are getting better or worse over time, or how close we are. You know, if we look at response times, we can start measuring these kind of trends, the red line being don't go past that line, and start to see that, unbeknownst to us, our average duration is getting worse over time. That'd be good to know earlier rather than later. As a matter of fact, if we take a look at concurrency, in other words, the concurrent users, that's users actively submitting something, hitting the enter button, and start tracking this, we realize that, well, that demonstrates a fairly scalable system. These are ways of also being able to generate these kind of metrics to actually show and demonstrate, yes, our systems are scaling, and I can prove it. Look at what this trend is looking like. As we start increasing the total number of concurrent users, we've got peaks and valleys, but pretty much our average response time is remaining the same. That is the definition, one of the definitions of a scalable system and scalability. So here's the bottom line. Well, if you can measure it, then you can define it. Interesting. What, and I don't even have it here, what does it mean to have a system that's reliable? Your business stakeholders say, well, reliability is absolutely necessary. Okay, how do you define reliability? Let's take a step back and say, what would I measure? Interesting. What would you measure to see if a system's reliable? Well, what's the error rate? How much errors are occurring? Is it available? When I retrieve data and then I immediately retrieve it again, is it accurate? I can measure things like data integrity, fault tolerance, error rates, availability, and basically those four things, if I measure those, define reliability of a system. You may have other things that you're measuring, or you may have only 2 or 3 of those things that you're measuring, but that's one of the ways of defining what all of these things actually mean. All right, so I spent a lot of time on that because it is the grounding piece to make basically any kind of trade-off analysis. But I want to spend just a little bit of time showing you another aspect of architectural thinking. Because if we're going to apply architectural thinking to our daily work, regardless of your role, one of the things we have to do is increase our technical breadth. You see, this triangle right here represents all the knowledge, technical knowledge in the world. And that's the stuff you know right up there. That's the stuff you do every day. But right below it is another area of knowledge. This is the stuff you know you don't know. You've heard of it before, like let's say Clojure or Scala or whatever programming language or a particular framework. You've heard of Hazelcast, but you haven't used it yet. That's a good example of stuff that you know that you don't know. But then the largest part of knowledge is the stuff that you don't know that you don't know. You've never heard of that stuff before. And the problem is this stuff here is probably the perfect solution to your problem, just a perfect fit, and you don't even know it exists. So the whole game in the career and life is to take things you've never heard of before, just find out what it is, and that then starts increasing that middle area of knowledge. And then something that piques your interest or you start using, then move that into the stuff you know, therefore increasing that area of knowledge. Now, cautionary tale here, watch out for the stuff you know, because you got to maintain that stuff. Unless you don't have kids or you don't sleep, be careful about what you put there, because if you don't maintain that stuff, then all that precious knowledge and expertise starts trickling back down into the stuff you know you don't know, just like teardrops. Now, the stuff you know is technical depth, but the stuff you know combined with the stuff you know you don't know is technical breadth. Architectural thinking does require you to place some level of focus on that technical breadth at the expense of technical depth. Now, what I want to show you is really cool here. Let's say we have a natural progression in your career, a junior developer, then you become a senior developer, then you become a junior architect, and finally a senior architect. Okay, let's say this is a standard kind of career path. Well, let's take a look and open up the hood on our brain, actually, and let's see what the knowledge triangles look like and compare them with each of these roles. Because this is a knowledge triangle of a junior developer. Notice we've got some stuff you know right here, but look at the stuff you know you don't know, that technical breadth area. It's pretty small. And as a matter of fact, you don't know a lot of things. You haven't heard of a lot. This is pretty indicative of a junior developer. Now, watch the transition. Watch what happens as you move to a senior developer. Ready? Watch the triangle. A senior developer starts increasing your technical depth. You start to become an expert in more and more frameworks and languages and tools and products and all these things. But as a senior developer, your focus is still on your technical depth, not this technical breadth right here. Now watch what happens, interestingly enough, when we start moving into that role of an architect and start applying that architectural thinking. Are you ready? Moving here as a junior architect, notice starts increasing that technical breadth, the things that you know you don't know. So you know a little about a lot of stuff at the sacrifice of the stuff you know. And that is a pretty accurate picture of a junior architect. Now, when we move over to a senior architect, that's where, notice, the technical depth didn't change much, but the technical breadth did. And so when we compare a developer from an architect, we notice the biggest difference is this focus right here on technical breadth. For example, it is far more valuable in architectural thinking to know that there are 10 different caching technologies and tools available, and kind of the characteristics of each, than knowing Memcached extremely well. Because your problems are all going to be solved with Memcached, and maybe that's not the appropriate fit. There's 10 others out there that might be. And that brings a lot more to the table when we're trying to solve solutions and starting to think architecturally. All right. Well, I know that we're kind of running out of time. I've got about 5 more minutes before we start a Q&A, but I did want to talk about the third factor before we kind of leave. And that is architectural thinking is all about analyzing trade-offs. As a matter of fact, Neil and I in our first book coined the first law of software architecture, that everything in software architecture is a trade-off. Everything. As a matter of fact, we have a first corollary, and it's stated here in our book. If an architect thinks they've discovered something that doesn't have a trade-off, more likely all it means is they haven't identified the trade-off yet. How do you analyze trade-offs? Well, let's take a look at kind of a flow of how to do modern trade-off analysis. And this is extracted from our book, most recently published, Software Architecture, The Hard Parts. So it all starts with the business drivers. I maintain personally that you cannot make a decision and analyze trade-offs without the business driver. So let's say time to market is the biggest concern of the business. We have to get features out faster than our competition. Have to, or we won't succeed. From there, we just saw the first piece was that translation engine in architectural thinking to know, well, that means maintainability, testability, and deployability. Now we have a trade-off. Should I make one large consolidated service or break it up into 3 different services with its corresponding data? And what we realize is what that corresponding trade-off becomes is a matter of performance versus maintainability. Now, unfortunately, and I won't get on my soapbox and bandwagon about this, too many teams pre-optimize for performance without really understanding what those underlying drivers really are. Well, now we trace it back to the architecture characteristics and we see, wait a minute, maintainability is one of our main drivers. And then we trace it back to the business drivers and realize, yeah, business isn't concerned about performance. IT teams may be, but the business doesn't care. They're more concerned about time to market. And therefore, that's how we make a decision and a trade-off analysis, in this case, to break apart services. So there's a couple of tips I want to show you before we kind of start the Ask Me Anything kind of thing. And this will be probably about another 5 minutes or so. And the first tip is to watch out for this very common trap called the out of context scorecard trap. And let me show you what I mean. So I can't decide whether to use a shared service or a shared library, like a jar or a DLL, for the common functionality in the system. I don't know. I've got both those options. How do you make a decision like this? Should I wrap all that shared functionality into a DLL, or should I just create a shared service? Well, let's actually analyze the trade-offs. So for example, for heterogeneous code, a shared service is much better. And because if I've got 4 different languages in my ecosystem, a shared library, I'm going to write 4 different ones. I'm duplicating all this code. For high code volatility, if I'm changing code a lot and frequently, well, a shared service, I don't have any deployments. If I have a shared library, I got to redeploy everything. That's a lot better. However, I can version changes a lot easier with a shared library. However, the dependency management, oh my word, and I'm not going to use the word Maven, it is really hard with a shared library. However, a shared service, well, services just invoke that. However, Overall change risk is a lot better in a shared library because I can version it. If I make a change to a shared service, that's a runtime change. And as a matter of fact, operationally, performance, fault tolerance, and scalability are all much better with a shared library because there's no remote call to make. There's nothing to go down. There's no dependency with another remote service. So clearly, if we add up the check marks, folks, shared library is the name of the game. There, I've just answered it all for you. Well, watch out for this trap because in the structural aspect, software architecture, there are no best practices. You cannot say it's a best practice to use a shared library over a shared service. It's just not true because it depends. Look at this. Well, what's my context? Well, we leverage polyglot programming and we have services written in 4 different languages, but performance and fault tolerance don't concern us at all. We have to manage frequent changes because that common functionality changes all the time. And if we look at our scorecard, that's our context. And that's why there's no best practice. Because in this case, a shared service suits us better because that's our context. And so just be careful of that scorecard trap or anti-pattern. Now, a lot of people do what's called weightings, not like waiting around, but put weights on different things. It's a good approach, but why would I put a weight on something I absolutely don't care about? Like performance isn't a concern. So why should it even have a weight at all? It usually goes to 0 because it's not a concern of ours. Now, weightings is a good technique if we kind of are concerned about some of these things, but others more so than others. If we don't care about something, just put the weight as 0 because it doesn't matter to us. It's not within our context. All right. Do y'all want to see one more tip before we go to the questions, or should we move on to questions? I got a lot of tips here, a lot of pro tips.
We've got time. Let's do another 1 or 2 tips.
All right, we'll do another tip. This one I love. So this is another pro tip when we're analyzing trade-offs. Yet another trap to avoid getting into. And this pro tip is to make sure you model all the relevant business use case scenarios when we're extracting trade-offs. And let me show you this one because this is pretty good because this is a common one that most people kind of run into. So, I wonder, should we have a single payment service for all the different kinds of payments that we can make on our website? Or should I create a separate payment service for each type of payment? Credit card, PayPal, Venmo, gift cards, all that kind of stuff. Well, I don't know. How do we make that kind of choice? Trade-offs. Analyze the trade-offs, and let's do that. So, well, what do? Well, we got to update the credit card processing quite a bit. Okay, so let's do that scenario. Here, I have to actually update the payment service, the single payment, and the corresponding data. But the problem is, that's my testing scope, folks. So my testing scope is fairly large because I still have to test other payment things. It's common code in there. I've touched a service. I have the responsibility of testing it all. And that is also my deployment scope. So I've got additional deployment risk as well. But what happens if I break apart the services? My testing scope is just to that functionality. As a matter of fact, that's my deployment scope. I can deploy the credit card and we're still processing PayPal and gift cards. So, wow. Well, in that case, separate is better because we get better maintainability, testability, and deployability. Wow. But let's keep going because we got another scenario. We do have, and we do occasionally add new payment types. As a matter of fact, What we're implementing now are reward points that you can actually use for discounts or even to use as real money. Well, here I'd have to add that code. I'd have to add and modify the corresponding tables, impacting a lot of the functionality, maybe all of it. So again, larger testing scope, larger deployment risk. Watch this, folks. Are you ready? If I separate the payment types, all I have to do is write the code, create the tables, put it in a bounded context, put it in a container, and drop it in. That's it. Which would you rather do? Clearly, the separate one. And that's all about extensibility of our systems. A great example, by the way, of what extensibility really is. So clearly, have I convinced you? Separating the service is absolutely what we should do. Folks, watch out for this trap. It will bite you. Because, don't forget the pro tip, did we cover all the possible scenarios? Although getting excited about the fact that separate seems clear, yes, there's another scenario, folks, because we can use multiple payment types anytime we pay for an order. Oh, right. Well, in a single payment service, it's just a matter of invoking another class file. We've got the single database. We've got ACID transactions. Yeah, it's actually pretty straightforward. We're just making method calls. Whoops. What would we have to do if we separated out all these services? Well, first of all, we'd have to create another service which acted as the orchestrator. We'd have to move every endpoint from our API gateway to point to the orchestrator, even if it's a single payment type. And furthermore, not only do I have to create a new service, and now I've got multiple network hops, but I also have a distributed transaction now. I can't do commits and rollbacks on different payment types. Oh, so separate ones are going to have a performance hit, definitely, and also potentially data consistency for rolling things back when I can't do a quote rollback. These are distributed transactional sagas. So what's more important, performance and data consistency or extensibility and agility? And so if we take a look at some of these tips, which are by the way, on the last chapter of our hard parts book, we can start to see that these are common traps we fall into in kind of the trade-off analysis pieces that we do. So that's what really is meant, folks, by architectural thinking. It's really applying all three of these things, understanding the business drivers and translating those to what characteristics are important. Please use that sheet that I showed you guys, showed you folks. And number two, it's about starting to expand slowly our technical breadth. And number three is to apply these techniques of modern trade-off analysis, using those characteristics as the basis, and watching out for the scorecard and the relevant use cases piece, to be able to make the right choice in any solutions that we have. And so, all right, fantastic. So I know I went a little bit over, but I just get really excited about this stuff. This would be a good time to just open it up for any questions regarding architectural thinking, or just anything at all that's related to kind of architecture or whatever topic.
Perfect. All right. Well, while we've got people kind of racking their brains for questions, or if they've got something, again, feel free to use the ask a question. I'm going to pull up some of the questions that I've got. Now,
Sure.
I don't think anyone else saw this, but I saw it before. So you have a number of different violins over there on your wall.
Oh, yes.
Yes. Tell me about those.
Well, yes. So the top one that you see over there, of course, is my rustic fiddle. That's kind of a. Let me start. Do you know the difference between a violin and a fiddle?
I saw a video about that.
Ah,
Actually, a couple of days ago.
here's the answer.
And what Lindsay Sterling said is it depended on how you played it.
That's right. A fiddle has beer stains on it. It is the exact same instrument. It's a style of play. You can do kind of pop music. I play Metallica on my electric violin.
Very cool.
I do Irish jigs. You can do reels. You can do kind of country. Yeah, it's the style of play. So usually fiddle is more Irish and country and kind of uh, that kind of very fast paced kind of music. Whereas when you think about playing a violin, it's more like a concert, a symphony, slower songs and stuff like that. But yeah, so the top one's called a rustic fiddle. That's the regular old violin. The black one that you see here is one of my favorites. I love this guy. This is my electric violin. Now this has an interesting story to it. So it hooks up to an amp. But I used to take my rustic fiddle with me when I traveled because I like to play and I like to practice.
Sure.
Well, the number of calls that I get from management up in my hotel room because it is loud. A violin is loud. And also my family, every time I play would be like, do you have to play that horrible thing? So this you can barely hear. So I take this traveling with me. It sounds really great on an amp, but also I can practice and I don't bother anybody in the house. So, but the third one you see there is something called a 1700 player's fiddle. So 1700 being like the 1700s in the old days, where fiddlers just used to run around with the fiddle on their back, and it's got a different shape. It's very narrow. I love that fiddle because it also has a passive mic amp hookup, but also it's just really portable and light. So yeah, I've got.
Let me see if I can if we can focus on you because at least for me, since we're split screen, I can see about to the edge of your bookshelf, but no more. Let's see if we focus, we can get everything.
Right. So yeah. So this guy, this is the 1700s. Player fiddle. It's super light. It's just really light, but it's also portable. I love traveling with this baby, but it's got a great sound. It resonates really well, but I can also hook it up to an amp for special effects. So yeah, so those are my three fiddles.
Very good. All right, so we've got a question from Michael Green. This is going back to the presentation. He says, in regards to the knowledge pyramid, how do you avoid becoming a jack of all trades and master of none as you become more experienced architecturally?
Yeah, it does happen, and as a matter of fact, it does create something called the imposter syndrome. It's happened to me. It's happened to a lot of my colleagues that are architects, where you do start to feel like you're a jack of all trades, master of none. A couple of ways to avoid that. First is you'll notice in that knowledge triangle that you increase your technical breadth at the sacrifice of your technical depth. It really, unless you're a super person, it's really hard to continue to maintain all that deep technical knowledge and keep it current while you're starting to go broad. So the first part of the answer is to make sure that you do stay hands-on and technical. Choose areas that are either really interesting to you, that you're really, really good at, that are marketable. And those are three really good ingredients to just start narrowing down. A really good example. I helped start the Boston Scala users group way back when, about 12, 14 years ago. I loved the Scala programming language. I spoke spoke about it at conferences. I was doing gigs in Scala. I just really dug the language. Well, as I started to increase my technical breadth, I had to start giving up stuff. And I realized, well, it's not mainstream. It was more kind of this is a really cool language. And so I just dropped it. And now that went from something that was something I know now into something I know I don't know, but kind of towards the top there. So it really is just picking and choosing what things to sacrifice. But that's part one. Part two is really just knowing that that jack of all trades piece brings an incredible value to your team. An awareness of different frameworks, different languages, different tools, different products, different techniques, different patterns that you can start applying and work with your development team to say, you know, the such and such pattern might actually work well here. What do you mean? I've never heard of that. Well, let me show you, blah, 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 blah. Actually is far more valuable when you're forming solutions and building software than being a really good programmer. And so it's just knowing and focusing on the fact that that is bringing value to your team. Both of those things really do help avoid that kind of trap. But just stay hands-on. Yeah, that's a key.
Very good. All right. So again, if anyone's got questions, feel free to ask them. If not, we'll go over to questions that I've got. So we in the green room, Mark, you and I mentioned a little bit about astronomy. So I'm going to give you a chance to geek out a bit. Why don't you talk about the James Webb Telescope and what your thoughts are on some of the images that have been released?
Oh, wow. Yes. So awesome. Yeah, I started my career actually as an astronomer. I worked at Braeside Observatory in Flagstaff, Arizona. And we were chartered through NSF grants to look for black holes, variable stars, binary star systems. So we did a lot of photometry, which is a classification of what's called observational astronomy, as opposed to during the day using, radio and all sorts of stuff. But we actually had a telescope and looked through it. But I'm fascinated by some of the things that we're seeing in the images because it's always been well, one of the things that got me into astronomy was kind of that meta question about, if you keep going further and further and further out, like what's out there? And it's like, well, empty space. Yeah, but what's beyond the empty space? And these start boggling the mind. And it's really exciting to me, especially as an astronomer, to be able to get a glimpse of history. I mean, when you look at a distant object, a galaxy, a cluster, whatever, you're looking in the past, potentially tens of thousands to millions of years, light years in the past. And this is also always just kind of boggled my mind as well. That when you're just looking at our closest galaxy, it may not be there right now physically. So getting these glimpses is just absolutely amazing. So yeah, I'm geeked out about this stuff.
Very cool. So what that surprises me that everyone has their own journey that they've taken. And you said you started off as an astronomer. So what briefly, what has your progression been from astronomy to software development to speaker to architect to all of these things?
Yeah, so part of my role at the observatory was also telescope automation. So I was programming on Apple IIe's with C language and assembler, and we were trying to automate the telescope as the dome slit rotates, as the telescope slews. The dome has to track it. We had to manually go up to the telescope. This is a huge telescope. And we had to manually change the filters from gathering light. And so we automated all this stuff and then did a lot of data reduction routines and stuff and programming. So I was already doing some coding. But the hours were long. I mean, I started work at 10 p.m., finished work at 7 a.m. once I did all the data reductions. And of course, what do you do after work? You go out and grab a beer, and that wasn't really healthy for me. No, I'm just kidding about that last part. But you were tempted to go grab a beer in the morning. That's a little weird. But no, I did get an offer once I moved here to Boston to the Harvard Smithsonian Astrophysical Observatory. And the pay was so low that I wasn't able to afford an apartment here in Boston. So that's when I just realized, maybe I should do this as a hobby and just kind of go into computers. And so that's what I did. But from there, I did the very traditional uh, track from a junior developer, senior developer. About 26 years ago, I had my first opportunity as an application architect and just kind of moved from there. But about 12 years ago, I've always been consulting and still do some consulting. But it just dawned on me that I've got all of this knowledge that I've just gained through 36 years of experience. And I realized, it's not doing the industry any good for me to be buried on a development team working on code and stories and projects. And so that's what prompted me to start doing more training. And I just got some great opportunities. I loved it, really passionate about training. And so the split has gone about now to 20% consulting, close to 80% training, conferences, just doing videos and stuff like that. So, and that has been my journey, and it's continuing.
Excellent. All right. I will ask this question by Gary Ray. He says, as someone progresses from developer to junior architect and on to senior architect, that is often done by changing employers. In those changes, you leave projects and often avoid experiencing the pain of your own past decisions. Can you talk about the trade-off dealing with longer-term maintenance of project versus moving project/employer to project as you progress up the career ladder?
Yeah, I certainly can, because I've actually had a lot of experience in that. One of my personal litmus tests, if I'm choosing to leave a project or leave an employer, is I ask myself, am I learning anything from this particular project? One particular project I was on was not great technology wise. I mean, it just was a COBOL to Java conversion. And, technology stuff. It got my first introduction to microservices, which was kind of cool way back nine plus years ago. But, the technology stack was pretty rudimentary. Yet I stayed at that gig for over 6 years because the new techniques in microservices at that time, which was barely coined, really intrigued me. But it was more, I was still learning about leading teams, managing large teams and people skills. And I was still learning. And so it's not all just jumping to the next technology stack. It's kind of investigating, are there pieces that I'm missing in my architecture journey that I can gain from this particular project or employer? And so that's usually my litmus test. One of the other cautionary tales that I've been watching out for is I try to avoid, obviously as a consultant, sometimes I have a 2 or 3 month gig, that's fine. But I try to avoid dead end technology stacks because unless I'm really learning something else, I'm really not furthering my career. And that's another litmus test for me to say I need to move on. I need to kind of further get into more modern and progressive technologies or languages or stacks. So that's another thing that I experienced way back in the 80s when I was coding PL1. And I was having a ball with the language and just realized, I woke up one day and I said, I'm never going to use this stuff again. There's no market for it. And so that's when I tried to form an exit strategy.
Very
Yeah.
good. All right. This one's from Tyson. And they say, what is your most recommended introduction book to software architecture? I'm going to rephrase that. And what are your first two? Because as a fellow author, right, the first one ought to be your own book, right? So what are the first two?
Wow. Well, aside from my books, a couple in particular that actually have made a fairly large impression on my career. As a matter of fact, I've got them here in my bookcase buried somewhere here. One of the ones which I really love to recommend is Gregor Hope's book, The Architect Elevator. And we think so much about the technology parts of becoming an architect or furthering my career, for example. But it really talks about the role of the architect as communicator. And, this is a really important topic. And Gregor just does such a wonderful job with it. So I really enjoy that book. That's a great one that's kind of non-technical in nature. Another one that is similar is A Practical Guide to Enterprise Architecture by Scott Ambler and a whole bunch of other folks. Now, this is an older book. This was written, I believe, in 2007. However, it was the first book that I read that actually really did start addressing the people skills and communication, kind of as a prelude to Gregor's book. So those two are just fantastic books, and it had enough technology piece as well with it. So those would be two that I would very much recommend.
Very good. All right. So this next one, what are some technical depth items / topics that you have maintained?
Technical depth. Well, I've stuck with Java because most of my clients are still in Java. It's a mainstream language, and it's pretty easy to get a consulting gig. So I've kind of programming wise have stuck to that, but branched out into areas of interest. For example, caching is something that I just really keen on. So I do a lot of classes in caching, different techniques of leveraging caching. So that's another kind of technical depth area where I have kind of maintained and kind of accelerated my technical depth aspect on that. Other than that, microservices, of course, which covers a gamut that's wider than service-oriented architecture nowadays. But
Right.
but yeah, those would be some. I've probably programmed in about 4 different languages, but those are kind of more less in the depth area now, just because I just like kind of programming.
Fair enough. Now, do you ever tell your caching clients they need to refresh their invoice number?
Oh, yes. There you go. Yes. Oh, well, you do know, of course, the 2 hardest things in computer science: cache and validation and naming things. Oh, and off by 1 errors.
Right.
Oh, yeah. Everybody knows that joke by now. Yes.
Oh, yeah. It's a good one. It is a good one.
It is. I still love that joke. I still get a kick out of it.
Very good. All right, we've got one from Michael Green. What is the hottest technology or technique on your radar right now that you think will gain traction? And what is the hottest item you think will fizzle?
Wow. Hottest item. I think I'm going to broaden it to say what's the hottest topic that I think is gaining traction. As a matter of fact, I have 2. One is architectural governance. And when I talked in the presentation part about those fitness functions and stuff, it's one small aspect of architectural governance. But as we start getting more complex systems and more complex requirements, it's getting harder and harder to really, determine if we have the right architecture, if we're maintaining all of the business needs and characteristics, how to accurately measure those, but also just how to observe those kind of things. If I make an architecture decision, the last thing I want to do is to stand over you and make sure that you're following it. No, I want to do other things like go on vacation. So things like ArcUnit, NetArcTest, ArcUnit Net, these are ways of actually writing code. And so when we talk about, do you still write code? Oh, yeah. I write code all the time. And a lot of times I write code as architectural governance functions. So this has been a hot topic on my radar for about the past 3 or 4 years, and increasingly, number of consulting gigs to basically spin up and start up an architectural fitness function base have been pretty common. So that's one topic area, but the other is data. And really just something I see as a glimpse of the future of software architecture. And that is just bringing data closer to the user. This kind of model we've been stuck in for decades about the database just being a repository for data and having to go out and get it and retrieve it. Oh my gosh, we somehow, I don't know what it is yet, but somehow have to break that kind of model and be able to bridge the user with the data closer. Caching helps in that, which is why it's one of my kind of topics I love to keep technical depth on. But that's another area that I'm seeing some advances in, but it is another hot topic in my opinion, or will be.
Great. Very good. The follow-up question that you had on that one is, what is one of the hottest topics, as you said, that you think will fizzle?
Oh boy, what will fizzle? Oh, I wish I had a crystal ball. That would be awesome. I think, well, one of the things I have kind of seen sort of fizzle is a lot of the constructs that we had within service-oriented architecture. These ideas of integration hubs still useful and still have their place. As a matter of fact, I did one of my lessons on, is SOA dead? And the answer is no, of course it's not. It has its uses. But increasingly, I've been noticing we're finding more effective and cheaper ways of being able to accomplish what those large enterprise or ESB service buses or integration hubs were trying to accomplish. That's something that, at least in my experiences in consulting, have kind of seen waning a bit. Now, microservices, in my opinion, has really led that charge, with orchestration really being delegated to orchestration services rather than a big integration hub gluing everything together. The concept of a bounded context, just at least for me personally, and what I see at my consulting gigs, continues to just solidify and solve really hard problems. So yeah, that would be one thing I guess I'd see that is probably something that we all got excited about 10, 12, 15 years ago that's, needs a real use case for nowadays.
Right. Very good. Let's see. So that's all the questions that we have from the audience at the moment. I've got a couple more that I would like to ask. And most of mine are not technical questions. I don't mind the technical questions, but it is nice to get to know the person, right? Not just the presenter that's talking about the technical stuff, but the person itself.
Sure.
So you said you really enjoy hiking. You said you were out here in Moab a little while ago. So what gear do you use? Where have you been, and what has been your most challenging hike?
Oh wow, yes, I've been hiking since I can remember. I've had a couple of very memorable hikes. Mostly
I like the way that you phrased that.
memorable. Oh boy, mistakes were made. How about those 3 words? Yes. So let's see. Where do I even start with that? My first very large hike. My wife and I decided to go down the Grand Canyon and go from the South Rim all the way down 10 days over to the North Rim, and that was fun. My pack weighed in. Are you ready? At 75 pounds.
Oh goodness!
Started the hike at 75 pounds. Now this goes back. This is over 30 years ago. But
how much of that 75 pounds did you leave on the trail?
I can't tell you that. I'm not allowed to say. Not much of it, actually, but a lot of lessons learned in terms of lightweight gear and the
Right?
importance of lightweight gear. But probably one of the most memorable ones was a follow-on hike. We got so excited about that. We did the north rim of the Grand Canyon. Again, another 10-day hike. We spanned about, I think it was close to about 130, 140 miles along the rim.
Exactly.
That was pretty memorable in that the very first problem we hit was that we realized there's no water on the north rim of the canyon. There's no water sources. And, we have maps at that point. This is way before GPS. These are all topo maps and stuff. And we identified streams and they were all empty. And so we hit significant water problems on that. And that was one of the first things. We went off one of the logging roads and decided on the north rim to camp like right at the edge. And we encountered a mountain lion, and that was pretty scary. I was holding my knife out. We were in the tent, and I'm holding my knife, and my wife says, "What are you going to do? Attack it?" I said, "No, I'm going to cut a hole in the tent and run." But lots of lessons.
She's still with you to this day.
Yeah, well, yeah, but yeah, we had a wonderful time these past couple of weeks in Moab and the surrounding area, Canyonlands. We went to Escalante, Bryce, and Zion. It was fantastic. We loved it. We didn't really run into any adventures like we did in our youth, but but yes, it is one of my favorite activities is hiking. Yep.
Very good. All right. Well, unless there's any other questions that come up between now and the end of this next one, I think we'll end on this one. So I was perusing your LinkedIn profile, and it looks like you've been involved in something for about the last 7 years, and it was called Christmas in the City.
Oh yeah.
What can you tell us about that?
Yeah, that's it's kind of an organization that is here in Boston. Well, I don't know if it's other places, but we do it here in Boston. That basically brings disadvantaged kids and families into the city, and it's basically as a volunteer, you kind of wrap presents, you deliver presents, but it's kind of just a really neat thing. So that people donate all sorts of toys and clothing and stuff like this, and it's just something that both my wife and I got into and just really kind of enjoy. So that's one of our holiday activities that we actually do and volunteer for. But really good program that they have.
Excellent. Very good. All right. Well, I think that'll do it for us. Do you have anything, any other little tidbits or parting wisdom you'd like to give us?
Just you can follow my website, developer2architect.com. The lessons, I took a little break because I am on vacation, but starting August 1st, I'm going to be back to my 2-week cadence. Every Monday, I do a different 10-minute video. You can watch it on YouTube or in the website itself on just some aspect of software architecture. So if you've never heard of it, there's about 136 lessons out there.
Cool.
But yeah, so just peruse those. I'm sure that there's some topic in software architecture that you're probably interested in, and it's just a good way to get a really quick tip on some aspect of architecture. So so stay tuned there, and you'll see me every couple of weeks.
Excellent. Very good. All right. So to close everything off, let's see if people are here so that they can win the door prizes. Do we have Sam Ney here with us? Sam, if you're here, just pipe up in the comments. All right. Awesome. So Sam, are you interested in a JetBrains license that works for any of their IDEs? Sam says, yep. And then Justin says, nope.
already have it. Yep.
Sam says he's already got one. All right. How about Tyler Pexton? Are you here? And are you interested in a JetBrains license?
Dad, after you're done with your meeting, can I go get something at the store?
We'll see.
Okay.
Yes and yes. All right, Tyler, that'll work. So let's see, who's our next one? Next, we've got Angelo. Conguess? Angelo, are you here? Maybe. Maybe. I think, let's see, I should be able to. Angelo was here, not here anymore. All right, let's see. This is cool. I can search for people.
That's great.
Let's see. Manoj, sorry about pronunciation here. Are you interested in a JetBrains license? Oh, this whole got to be present to win thing is killing me. And he says he's already got one. All right. Let's see. We've got Brett. Which one are you interested in? I've got a JetBrains license for you or the Agile Learner subscription from Venkat. Brett is interested in the Agile Learner. All right. And of course, I didn't think we'd go much more than 7, so that's all I've got for the random people. So now we're down to Jason just goes and picks someone that is randomly here. Rogelio Flores, are you interested in a JetBrains license? Nathan says, I'm here. All right, Nathan. Well, if Rogelio doesn't say, oh, he did. All right, awesome. So that should do it for us. Very good. And give me a license. Got it. All right, we will send that out to you. Again, so next month we've got Nate Shuda talking about, let me remind, some more microservices architecture kind of stuff as well, and also for an AMA. And then in September, we've got Steve. Steve, I think, are you still here? He's been with us. Yep, Steve is still here. Steve Afrin, he's a local here. He's going to be talking about the differences in Java from Java 11 all the way up to Java 17. So we're going to cover a couple of years worth of Java releases and look at what's new and exciting in that. So thank you, everyone, for coming. We look forward to seeing you next month. And thanks again, Mark.
Sure. Thank you for having me again. I'll enjoy. Good night, everyone. And hey, thanks for the listening and also the questions. It was fantastic. Thank you.
Excellent. Thanks.